Hey everybody, welcome back to class. Now, I know this is our third day of class, but this is our first official day of notes. Now, for those of you who don't know me, my name is Mr. Heading. I teach over in West Unit, so if you've never had me in class, that's who I am. Now, during this e-learning scenario, you're going to hear a lot of different voices. You're going to hear my voice, you're going to hear all the other Algebra 1 teachers. We're kind of carrying the load a little bit when it comes to creating videos, so that way it's not just me you hear all the time. So for my students, hey, I know I've sent a greeting before, but that's who I am. Now, what we're going to be doing in this video is talk about the key features of a parabola. So we're going to look at a parabola, we're going to look at the important parts of it, and so on. So this hopefully should be a review for all of you. I know it's been a little while. We're going to get out your best friend Desmos, and we're going to use that to get going. So for those of you who don't know, I love Star Wars, and in particular, I love porgs. I think they're great. This is my best porg friend, Philip. And if you're in my class, you know Philip. I said Philip would make an appearance. So we use Philip to talk about parabolas all the time. Now, instead of me trying to throw Philip in the camera frame, I've got something kind of cool. I've got something I call a porg launcher here. It is on Desmos, so it makes Desmos even better. But when I launch a porg, if I throw it into the air, what shape does it make? So let's go to my handy porg launcher, because no porgs are made or harmed in the making of this film. And I have an equation here. I hit launch, and there goes Philip, my virtual Philip. Isn't that awesome? I think it's pretty great. But we see that when Philip launches in the air, he goes up and then comes back down. Now, why in the world is he coming down? And you think about it for longer than maybe 2 seconds, you remember, oh, that gravity thing. So when Philip is launched into the air, he's flying, he's going up, and then he comes back down, assuming he doesn't use his wing. Now, this is a parabola, and it is used in all types of mathematics, and we'll cover some of that throughout this e-learning experience. Now, a parabola is the graph of a quadratic function, and it makes a U-shaped curve. It's used in any type of projectile motion. It's used in that. It's used in architectural design. In my class, we talked about how it's used in headlights in a car. So parabolas are all over the place. Now, if you're looking at this, your assignment for today is to do some guided notes. So if you haven't noticed yet, one of your first definitions is a parabola. So I would open it up and follow along. So you can pause the video, type in as you go. And by the end of this video, you should be done with it. So just so you know. So we have a parabola. It's a U-shaped curve, projectile motion. Now, I'd like to challenge you. You can tweet at me. Can you think of any sport that doesn't use a parabola or doesn't have a parabola in it? Think about it, tweet at me, let me know what you think. But these are created from quadratic functions. Now, you've talked about quadratic functions so far. You have factored, you have done a little bit of solving, maybe, depending on who you've had so far. But you should know that it's ax squared plus bx plus c. That is the form we're working with. Now, this is called, or a cannot be 0. That's kind of a big deal. So if a is 0, then there is no x squared. The x squared is what makes it quadratic. Now, standard form, if you remember, is ax squared plus bx plus c. Now, throughout this e-learning experience, we're going to learn a couple of different forms. In my class, we talked about something called Yintercept form. We've talked about that, or factored form, depending what you want to say. And we'll talk about something called Vertex form, but right now we're sticking with standard. These letters, A, B, and C, are all going to become important, especially when we talk about projectile motion. Now, in a parabola, we have this thing called a vertex. Now, it is the highest or lowest point. Let me underline something here. Highest or lowest point, a little box around that, on a parabola, also known as a turning point. Now, when I'm talking about the point, what I mean is this point right here. Oh, that's back there. I'm talking about this point right here. That is my vertex. It's where it changes from going down to up or up to down. So if this were Philip launching, it would be where Philip's maximum height is down to where he's going down. This is where the initial force, so how much force you put on an object, is equaled out by gravity. Now, again, not something you need to know off the top of your head, but an interesting fact. Now, with the vertex, there's something called the minimum. Now, this is not to be confused with the vertex. The minimum is the lowest y value. Let's get that bar to move. is the lowest y value on the graph. It is not a point. It is just the y value. You've talked about this in class before. So if I was looking at this one, my minimum here would be y equals -4. It is a value, not a point. And conversely, well, in the same manner, we have the maximum, which is the highest y value. Now, again, this is the y value, not the point. So if I'm looking here, my maximum will be the point y, or the value, sorry, y equals 4. It is a value, not a point. So again, I'd write that in your notes. Next, we have this thing called the axis of symmetry. So symmetry is when something can be cut down the middle and is equal on either side. So for example, here I have another virtual Philip. And so if I were to virtually, not actually cutting him in half, if I were to virtually cut Philip in half, he is symmetrical. We could kind of fold him over. Now he's kind of tilted to the side, but you get the idea. If I were to fold Philip over, he matches. Same thing with a parabola. So with a parabola, we can have this line down the center, and it makes it symmetrical. So it can fold it on top of itself, and it's the same. Now, the axis of symmetry always goes to the vertex, because the vertex is kind of the center point of all of this. And the equation for this is x equals the x coordinate of the vertex. So it's a line. Okay, so this is a line. Make a little note of that. And it's x equals the x coordinate. So in this case, my axis of symmetry would be x equals 1, because you see here, that's that coordinate of this point. Now, the other thing we need to talk about is things called zeros of a function. Now, these are the x values that make the function equal 0. My face is in the way, sorry. So the zeros of the function, we have one right here, and we have one right here. They're the x values that make the y equal 0. Now, there's two other names for this. These points are also referred to as the x-intercepts, or they are referred to as the roots. You may hear all three of these terms kind of interchangeable. Sometimes people will call it a solution. You might hear that sometimes, but I'm personally not a fan of it. But if you ever hear solution, that's what it means. We've got x-intercepts, roots, zeros, all of those are the same thing. Now with that, besides the x-intercepts, it is where it crosses the x. Oops, we don't want that. It's where it crosses the x-axis. And when you're solving these are going to become important. You can have a 0, 1, or 2 x-intercepts. It's possible to have no x-intercepts. It's possible to have 1, or it's possible to have 2, depending on what's going on with the parabola. So just look at your case. If you don't see where it crosses the x-axis, then it doesn't have one. You also have this thing called the y-intercept, and it's where the graph crosses the y-axis, and you're guaranteed to have one. So you're going to have a y-intercept. All right, so we're going to have a y-intercept, maybe 2 x-intercepts, or 1 or 0. So let's look at Desmos. So in Desmos, we are going to find all of the different pieces. So let me pull up Desmos here, and I'm just going to type in my solutions so that way you can read them. So we're going to find the zeros, the vertex, the axis of symmetry, all that good stuff using Desmos. So let's jump in, and I'm just going to start by typing it out. So we've got x squared plus 5x plus 5x minus 6. Looks like that, and oh, it's pretty hefty, so let's zoom out a little bit. So let's go in order. Now, if you click on the parabola, it highlights these gray points, and these are all of our points of interest. So our x-intercepts, you see right there, we click on those dots where it crosses the x-axis. So I have the points -6, 0, and 1, 0. So these are points. Make sure you write those as points. Next, we have the vertex. Again, that is a point. So make sure you come over here and look, Desmos highlights it for us, so we don't have to look for it. And it is this point right here. So make sure you type it as a point, -12.25. Okay, now the axis of symmetry. It is that vertical line that goes through the center. Now to do that, remember you have to do x equals the x coordinate of the vertex. So in this case, it's negative 2.5. Negative 2.5. And so you see here, I type it in and I see a vertical line that cuts it down the center. Excellent. So I have x equals negative 2.5. Okay, so the y-intercept, that is also a point. And so our y-intercept is this point right here, 0, negative 6. We're going to type that. And maximum or minimum, well, this is a minimum at y equals, well, the minimum value is, minimum, we'll say is, y equals the lowest point. Now, I know it's a minimum because it's at the bottom. So the lowest value here is negative 12.25. If you didn't notice, is the y-coordinate of the vertex. So it's just that. So the vertex is really important. And that's it. I found all the key features using Desmos. So type it in, look at the stuff, and you're good to go. Now let's look at something a little bit more interesting. So a little bit more interesting. Let's say Stacy is firing a rocket. She determines that the rocket flies on the path of that, and X stands for time in seconds, Y stands for height in feet. Okay, so we've got X is time. I'm going to highlight that. So we've got X is time. Let's make that red. I've got Y is height. Let's make that green. So that way we know kind of what we're looking at here. All right, at what time will the rocket be at its highest? Okay, let's first start by typing this into Desmos. So I got Y equals negative 16x squared. Let's see, plus 100x. Oops, 100x. Okay, so let's zoom out just a little bit so you can see the whole thing. We're getting there. There we go. So here's our parabola. And this kind of models what's going on. So we're looking for when will the rocket be at its highest. Now that word right there, highest, should let us to think about the vertex. So if I'm looking at the vertex, the highest, so the highest is right here, 3.125 and 156.25. So if I'm looking for time, that means x. That's why I bolded that. So I'm looking at a time of 3.125 seconds, aka the x coordinate of the vertex. Now for the next one, what's the highest the rocket will travel? Again, highest it will travel, that refers to the height. So if I'm looking at height, that would be the y coordinate. So the y coordinate here is 156.25. You know that's in feet because it says right here in the problem. Now, how long will it take for the rocket to hit the ground? It's a good question. So if we're looking at this rocket, we can see that it's on the ground in two places, here and here. Now, why would it be 0, 0? Well, if we think about it, when we're launching the rocket, it has to start on the ground. So that's what this point represents. So if I'm looking for when it will land on the ground, the answer here is 6.25. 6.25 seconds. It's not the point because I'm looking for how long it will take, not the point itself. So it'll take 6.25 seconds because we know X stands for time. So that kind of summarizes everything we're going to do. Let me change this date for you. This is due tonight on the 1st. Now, if you watch the video and had your notes open at the same time, you should almost be done. There's a couple questions at the bottom I want you to do that are just like in the video. So if you need to backtrack, watch how to do it. That's what it's there for. So best of luck. If you have any questions, let us know. Bye.